Hello, good afternoon. Am I audible?
theories இந்த கனெக்ட் பண்ணும்போது இந்த பாப்அப் வரும். இந்த பாப்அப் வரும்போது செட் டிஃபால்ட் கொடுக்குறோம். இந்த அவுட்புட் வந்து இதுல இருந்து கேட்குது, டிவில இருந்து கேட்குது. அதனால இந்த டிவி கொடுத்துட்டேன். பிளேபேக் ரெக்கார்டிங் வந்து இந்த மைக்ல இருந்து ஆகுது. ஸோ ரியல் டைம் ஆமா ரியல் டைப் அதோட டேட்டா. பட் இந்த மைக் பார்த்தீங்கன்னா இப்போ ப்ராப்பர்ட்டிஸ்ல போனா டிஜிட்டல் ஜாக்கு, இதுதான் டிஜிட்டல் ஜாக்கு. ஓகே, அதோட இது வந்து இங்க இருக்கு, அது ரிசீவ்ல இருப்பாரு, இது மட்டும்தான் இருக்கு. இதை நான் கனெக்ட் பண்ணிட்டு கான்ஃபிகர் நான் பண்ணிட்டேன். இல்ல ஹெட்செட் கிடையாது பாருங்க, பேசி நான் கேட்கல. செக் 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 வேற எதுவும் மைக் இருக்கு, இது வந்து வெரி சிஸ்டம் வந்து ஒரு ப்ராப்ளம். ஸோ இதை செலக்ட் பண்ணிட்டு இங்கே நான் கொடுத்துட்டேன். இங்க என்ன ஆகணும்னா இந்த ஜூம் இங்க போயிட்டு செக் பண்ணும்போது சேம் ஆஸ் மைக்ரோ இஸ் ஒர்க்கிங். அதனால ஆப் செட்டிங். Sir, am I audible?
Yeah, you are audible, sir.
Okay.
Notes Anything else? Sir.
Yes, can you hear me? So am I audible? So in the previous class, we have discussed about the discovery of electron and proton, right?
Yes, sir.
Yeah, so today we are going to study about the discovery of neutron, how this neutron it actually got discovered. And similarly, then we will see the various atomic models. We will also go through what is atomic number, what is mass number, what are isotopes, isobars, isotones, and other species also. So let's start. I will just share the screen, whiteboard. So is it visible?
Yes, sir.
Okay, so let's see the discovery of neutron. Actually, neutron, it got discovered late in 1932. So can you tell me who discovered actually this neutron? Discovery of neutron. Neutron was actually discovered by Chadwick. It's actually the talk of 1932. So that means this neutron, it got discovered late in 1932. Is this screen visible? So see how actually it got discovered. Neutron, it got discovered when actually alpha particles, they were bombarded on nucleus of beryllium. So I hope that you know what is actually alpha particle, isn't it? Alpha particle is simply, I have already told in the previous class that alpha particle is that particle which has charge of 2 units and mass of 4 units. It's actually your helium nucleus, right? Helium-2 positive, it is known as alpha particle, isn't it? Yes, any doubt?
No, sir.
Okay. So I was just saying that this neutron, it got discovered when actually alpha particles, they were bombarded on beryllium nucleus. So I'm just taking this nucleus of beryllium. So I hope you know its atomic number is 4 and mass number is 9, right? Isn't it? So if I'm just bombarding it with alpha particles, so how can I write this alpha particle like this? Helium, it is the helium nucleus. So this is actually a nuclear reaction. Helium, its atomic number is 2 and mass number is 4. So when it is bombarded with this, when this alpha particle, it is bombarded on this beryllium nucleus, what happened? A new particle got discovered here. So first this beryllium, it gets converted to carbon, atomic number 6 and mass number 12. And along with that, we actually get here a neutral particle, which is just represented by N01. So this was our neutron. So this is the discovery of neutron, how actually neutron got discovered. So it got discovered by just bombarding. This is my alpha particle. When this alpha particle, it is just bombarded on nucleus of beryllium. So this is the nucleus of beryllium. So it is just a nuclear reaction. So one is actually normal reaction, which we study, but another type of reaction is the nuclear reaction. Nuclear reactions are those reactions in which actually nucleus of atom takes part, isn't it? So here now, I hope that you are having this confusion in your mind that how this reaction will get actually balanced here. So see, it is here, we are having beryllium and helium on the reactant side, and we're having carbon and this neutron on the product side. Whenever we have these nuclear reactions, we just balance their atomic number and similarly the mass number. Atomic number and mass number is to be balanced here. So see actually how it is balanced. We are here having the atomic number, beryllium, it is 4, and here helium, it is 2. So that means 4 plus 2, that is your 6, right? And similarly, here you will just add this mass number, that is 9. And here the mass number is 4. So 9 plus 4, that is how much? That's your 13. And now here it should be also same on the product side. So you can see here that if I'm just checking the atomic number, here it is 6 carbon, and here it is 0. So 6 plus 0, so that's your 6. And similarly, if you just talk of these mass number of the products, here it is 12 and here it's 1, so that's your 13. So when mass number on the reactant side and that on the product side, it is equal, so that means your reaction is balanced, this nuclear reaction is balanced. Similarly, atomic number is also balanced. You can see it's here 6 and here it's also 6. So got it now how to balance the nuclear reactions? Is it clear?
Yes, sir.
Yeah. So let me give another reaction in which this neutron got actually discovered. So if we are now just taking the nucleus of boron, boron is having atomic number 5, so mass number is 11. Now, if I'm just bombarding it with the alpha particle, so alpha particle, it is just your helium nucleus. So I will write it like this, that is 2 and 4, 2 units of charge and 4 units of mass. So what will happen? It will now get converted to nitrogen. So atomic number 7 and mass number is 14. And along with that, we also get here the neutron. So neutron got also discovered here. With this reaction, you can also form the neutron. So now can you check that is it balanced or not? Is this nuclear reaction balanced or not? Can you check it out? So what do you have to check? You had to simply count. You had to simply count the number of here these protons and the mass number. That is actually the atomic number and mass number. So see here it is 5 and here it's 2. So that is 5 plus 2, that is 7, isn't it? And here you can also see it is 7 plus 0. So that is equal to 7. So on both sides, it is same. So that means it is balanced. Now you can also check it from this mass number. See here, it's 11 plus 4. Yeah, that's 15, isn't it? And here you can also see that it is 14 plus 1. So that's equal to 15. Correct? Have you got it? It's very easy to understand that how to balance these nuclear reactions. Simply you have to note down that whenever we are having any nuclear reaction, then you will just have different atoms on the reactant side and similarly on the product side. Now, what to do in these nuclear reactions? You have to just balance their mass number, and similarly, the atomic number should be balanced on both the sides, that is the reactant and the product side. So this is how actually neutron it got discovered. So how neutron got discovered? Simply by just bombarding this alpha particle on this beryllium nucleus, or just by bombarding this alpha particle on the nucleus of boron. So this nucleus, it actually, this neutron, it got discovered late in 1932 by Chadwick. So have you written down this? Shall we move to the next page? Have you noted down this?
Yes, sir.
Okay. So this was the discovery of neutron. Now, when this neutron, it was actually, its properties was studied. So it was found that this neutron, it is your neutral particle. So first of all, you will write that this neutron, it is not a charged particle. So this neutron, it is neutral. That means it has no charge at all. We have already seen that your proton is positively charged. Similarly, your electron is negatively charged, but this neutron is neutral. And then its mass was found to be 1.675 into 10 raised power minus 27 kg. So can you convert it into gram, first of all? How much I will write it in grams? Can you convert this?
1.675 into 10 power minus 24.
1.675 into 10 to the power? How much?
Minus 24.
Exactly, minus 24 gram, because we know that 1 kg, it is how much? It is 1000 gram. That means it is 10 to the power 3 gram, right? Yes. Now, can you tell me, is it same mass as that of proton? We have already discussed the mass of proton. So what was the mass of proton? Do you remember that? Raghu, can you tell me? What was the mass of proton? Yes, that was 1.67. Yeah, actually, if you write it exact, you can write 1.674 or 1.673 into 10 raised power minus 27 kg. So that means there is very little difference in the mass. But sometimes it is asked that which is having slightly more mass. So you can remember that neutron has slightly more mass as compared to proton. Otherwise, they have same mass, isn't it? See, if you just take the 2 digits, you can check it out here that if you just take the 2 digits after the decimal, that is 1.67. Here it's also 1.67. So there is a very little difference in their mass. That means you can say the mass of neutron and the mass of proton, it is nearly same. But you have to remember that the mass of neutron, it is slightly greater than that of proton. Got it? So how can you now define what is a neutron? We have already defined what is electron, what is proton. So can you define now what is a neutron? So I will write that it is that subatomic particle. Is that subatomic particle, isn't it? We are having these 3 main subatomic particles, that's electron, proton, and neutron. So that subatomic particle, which is neutral. So first of all, it is neutral. That means it has 0 charge, isn't it? And has 1 unit mass. So can you tell me what is 1 unit mass? It is actually 1 unit. It is the relative term. What is the actual 1 unit mass? That means that is actually 1.675 into 10 to the power minus 27 kg. Got it? So this is how to define neutron. And similarly, we have already defined what is electron, proton, and this was the neutron. Now, in nutshell, can you tell me if I am just talking of if you have to actually remember it, the actual mass, the actual charge of all these 3 particles, similarly, their relative charge and the relative mass. So I will just summarize it on the next page. Have you written down, have you noted down this?
Yes, sir.
Okay, so if I will just summarize these discovery of electron, proton, and neutron, I will write here that this electron, and then we are having proton, you can represent it by P positive, and neutron, it is just represented by small n. So can you tell me, first of all, electron, it was discovered by which scientist? J.J. Thomson, right? And similarly, proton, it was discovered by E. Goldstein. And similarly, then we studied that this neutron, it was discovered by the Chadwick. And now, can you tell me what is their, if I'm just talking of their actual charge? So can you tell me what is the actual charge of electron? It's your minus 1.602. Yeah, 10 to the power minus 19 coulomb. Okay, what is the charge of proton? It will be your plus 1.602 into 10 to the power minus 19 coulomb. Now, can you tell me what is the charge of neutron? Exactly, it is neutral, so that's why no charge. Now, what is the relative charge? If you have to tell not the actual charge, you have to tell it in terms of relative charge. So can you tell me the relative charge? Yeah, it is taken as -1, here the +1, and here the 0. Okay, then tell me the actual mass of electron. What was that? I hope you remember it. It was 9.11 into 10 raised to power minus 31 kg, right? Yes. Okay, what is the actual mass of proton? It is 1.674, you can write, into 10 to the power minus 27 kg. And that of neutron, it is 1.675, right? Now, can you tell me their average mass? Average mass. That is the relative mass. See, the mass of electron, it is, yeah, exactly. The mass of electron, it is very small. It is neglected, so it's taken as 0. Okay, what is the mass of proton? It is taken as 1 unit. And similarly, the mass of neutron, it's also taken as 1 unit. Got it? So have you noted down this? Now, can you tell me here that this electron, when it was actually discovered, first of all, there was the experiment carried by William Crookes. I hope you remember that. That was actually the cathode ray discharge tube experiment. So can you tell me about these cathode rays, where from they are originated? What is their origin?
Cathode.
Exactly, they are actually, they get originated from the cathode. Okay, now can you tell me what is the origin of the anode rays?
In between the
Exactly, anode rays. Yeah, this is very important. It is asked in the exam that anode rays originate from the anode. That is wrong. Anode rays do not originate from the anode. They are actually originated in between the cathode and the anode. That is actually the space between the anode and the cathode, right? Got it? Yes. Okay, let's move to the next page. Then we will study about the models, right? So first of all, but before moving to the atomic models, we will just study about the atomic number, the mass number, similarly different types of species. So can you tell me what is actually atomic number? It is represented by the symbol Z. So what is actually atomic number? It is simply the number of, okay, I will first write this definition. Okay, okay, let's write it. It is the number of protons. It is the number of protons present. It is the number of protons present in an atom, right? So that is the atomic number. Or you can just say, since protons have positive charge, so we can also say that this atomic number, it is the total positive charge on an atom. So now tell me, this is the number of protons. I have told it, for example, if I'm just writing that the atomic number of hydrogen is 1, so that means it has how many protons? It has 1 proton, right? Similarly, helium, its atomic number is 2. We already know this, so that means it has 2 protons. If I'm writing the neon, atomic number 10, so that means it has 10 protons. If I'm just writing the carbon, atomic number 6, so that means it has 6 protons, right? Similarly, if I'm having any element, for example, nitrogen, its atom, so it has 7 atomic numbers, so that means it has 7 protons in it. So it's the number of protons present in an atom, right? We're having the last element of the periodic table, that is the oganesson, Og. Its atomic number is 118. So how many protons it will have? It will have 118 protons, right? Now, we know that if we are having a neutral atom, then the number of protons, it is always equal to the number of electrons. So I will just write in neutral atom, number of protons, they are always equal to the number of electrons. It is equal to the number of electrons. So can I just say then that atomic number, it is the number of electrons present in a neutral atom, isn't it? So that means you can write the second definition for the atomic number. So that means atomic number is, it is the number of electrons present in a neutral atom, but it should be neutral, because if it is charged, then number of electrons will not remain same. So number of electrons present in a neutral atom. So that is your atomic number. Got it? Have you noted down this?
1 minute, so
Okay, sure. Have you written down now?
yes, sir.
Okay. So for example, if I'm just now telling that I'm having, let's say, O negative, it's my oxide ion. So can you tell me how many protons are there and how many electrons are there in this O negative? See, oxygen, its atomic number is 8. So that means it has 8 protons in it, right? But now if we just talk of electrons, see, it should have 8 electrons, but there is negative charge on it. Negative charge means it has actually gained 1 more electron. So that means it has 9 electrons. Got it? It has only 8 protons, but 9 electrons. For example, if I'm just writing the oxygen neutral, so that means it has, its atomic number is 8. So 8 protons are there. And similarly, there are 8 electrons. But when it is O negative, so that means it has actually gained 1 electron. Similarly, if I will just write O2 negative, divalent negative, so that means it has protons will remain same. So since atomic number is 8, so protons will remain same, but electrons will be 10 now. So is it clear? Have you got it? For example, if I will just write O positive, if I'm having O positive ion, so how many protons will be there? Protons will be same. So that is my 8 protons here also. But electron will not be now 8, it will be only 7 electrons there, isn't it? Because positive charge means it has actually lost 1 electron. Clear? Isn't it? So if I'm just writing here, for example, if I will just write N3 negative, that is my nitrogen trivalent negative. So can you tell me how many protons are there and how many electrons? Stage, can you tell me how many electrons are there in N3 negative?
3, sir.
No, nitrogen, its atomic number is 7, so that means it has 7 protons. But now it is having 3 negative charge, so that means it has gained 3 more electrons. So exactly there will be 10 electrons, right?
Yes.
Okay, so Meghna, can you tell me how many electrons will be there in this any positive? See, its atomic number is 11, so that means it has 11 protons, but electrons will be only 10 because it has positive charge. That means it has lost 1 electron, correct? It is just like this. For example, if I'm just writing it's my sodium 11, so it has 11 protons, it has 11 electrons, and now if I'm just removing 1 electron from this, what will be there? It will now become any positive. Whenever any atom loses 1 electron, so that means it will now have positive charge on it. So that means it will again have 11 proton, but electron will be now only 10 because 1 electron, it has lost 1 electron. Got it? Similarly, for example, if I'm having this fluorine, its atomic number is 9, so that means it has 9 protons and it has 9 electrons. Now, if I'm just giving 1 more electron, that means if 1 more electron is gained by this fluorine, if this electron gets added to this fluorine, it will now become F negative. So that means it has now 9 protons. Protons will remain same, but electron will now increase because there is negative charge. It has gained 1 electron, so there will be 10 electrons. Is it now okay? Have you got it? Is it clear to all of you? Yes. So we can say that if we are having any anion or cation, then the number of protons and number of electrons, they will not be equal, isn't it? Now, this was what is actually atomic number. Now, if you had to calculate the number of neutrons, how you will calculate the number of neutrons? So we have got how to calculate the number of protons, similarly the number of electrons. Now, how to calculate the number of neutrons? So can you tell me? Anybody? How to calculate number of neutrons?
Atomic number minus number of protons.
No, mass number minus number of protons, or you can say mass number minus atomic number. Okay, let me write it on the next page. For example, okay, first of all, you will write it here that number of neutrons, how to calculate number of neutrons. So number of neutrons, it's always number of neutrons, you can represent it by n. So it is equal to A minus Z. So you now know what is actually Z. It is your atomic number, isn't it? What is A? A is the mass number, isn't it? A is the mass number. So, for example, if I'm having oxygen, its atomic number is 8, mass number is 16. So, how many neutrons will be there? That is 16 minus 8. So, that is 8 neutrons will be there, right? Got it? Similarly, for example, if I'm just taking the carbon, atomic number 6, mass number is 12. So the number of neutrons here, it will be 12 minus 6. So that's your 6 neutrons will be there. But if you are now having lithium, its atomic number is 3, mass number is 7. So how many neutrons will be there? Can you tell me? How many neutrons will be there? Yeah, it will be 7 minus 3, that is 4. So you have to calculate the number of neutrons like this. Now, since we have got what is atomic number and then how to calculate number of neutrons, now tell me what is mass number. So mass number, it is represented by capital E. So it is simply sum of neutrons and protons. Sum of neutrons and protons in an atom. So that is known as mass number. Now, can you tell me why we are just taking only sum of only these two? Why not electron here? Can you tell me? I just told that
mass is very negligible.
Exactly. I had told it that electron, its mass is very, very small. So that is actually neglected. So that is taken as 0. So that's why we are not taking here the electrons mass, because that is very small, that is neglected. So that means mass number E, it is equal to number of neutrons plus number of protons. So for example, if it is given to you that if we are having an atom which contains 16 neutrons in it and let's say 16 protons in it, so what will be the mass number? So mass number, that's E, it will be equal to number of neutrons plus number of protons. So that's 16 plus 16. So that will be your 32. So can you name this element whose mass number is 32? Can you name this element whose mass number is 32?
There is sulfur.
Exactly, it is the sulfur, atomic number 16 and mass number is 32. So this is how to calculate the mass number. So have you written down this? Shall we move ahead on the next page? Have you noted down this?
Yes, sir.
Okay. So now I will just give more examples. First of all, now you will just here write how to represent an element. Representation. For example, if you will just write an element, let's say the symbol is E. So then its atomic number, it is written here, and mass number, it is written here. So that means atomic number, it is just written as subscript. It is known as subscript. And this is your superscript, isn't it? Superscript. In computer language, we call this as subscript and this as superscript. For example, whenever we write, for example, we write hydrogen, its atomic number is 1, so we write it here, and mass number is also 1, so we write it here. For example, we write calcium, its atomic number is 20, we write it as subscript, and mass number is 40, so we write it as superscript, isn't it? For example, we are having carbon, so atomic number here as subscript and mass number here as superscript. Now there is question for you. You have to just write the symbol of an element. Okay, I will just write it here. You have to write symbol of an element. You have to write symbol of an element which contains 10 electrons, 12 protons, and 12 neutrons. So can you tell me its answer? Just try it out.
Sir, will it be an ion?
Exactly, it will be your ion. So I will give you, okay, I will give you the options. For example, if you are having, let's say you are having neon, one of the symbol, then you are having Na positive here. You are having Mg positive here. You are having Mg2 positive. So can you tell me which is the correct? Which one?
Sir, Mg is positive.
Okay, I will write another one that is only Mg. So which is now correct? Exactly, it will be Mg2 positive, because see, it has 12 protons. You have to start actually from the protons, because atomic number, that is your number of protons. So that means magnesium, we already know magnesium, its atomic number is 12, so that means it has 12 protons, right? And similarly, magnesium, it will have 12 neutrons, because there is mass number is 24, isn't it? 12 atomic number, mass number is 24. So now we are having only 10 electrons here. So 10 electron means it has actually lost 2 electrons. So that means it is actually your Mg2 positive. This will be the correct option. Otherwise, it should have 12 electrons in it, but it has lost 2 electrons. So that's why it will be now Mg2 positive. So is it now clear to all of you? So shall we move to the next page?
Yes, sir.
Okay, so tell me, for example, if I'm just saying that I'm here having an element, you have to tell the symbol of the element. Let's say it is having 10 electrons and 9 protons. So can you tell me the symbol of the element from these two informations?
Sir, is it fluent?
Yes,
Is it fluent?
it will be your F negative, that is your fluoride ion. Got it? See, actually here fluorine, its atomic number is 9, so that means it has 9 protons. It should have 9 electrons, but here now it is given that protons are 9 but electrons are 10, so that means it has actually gained 1 electron. So that means you will write it like this, that is F negative, isn't it? Got it? It's very easy. Are you having any doubt here? Any doubt? Okay, then tell me that if I'm having bromine 35 and 80, so can you tell me the number of electrons, protons, and neutrons in this Br? That is your bromine.
Sir, number of electrons and protons are 35,
Yes.
and number of neutrons is 45.
So can you tell me first of all number of protons?
35, sir.
35, exactly, because atomic number, that is equal to the number of protons. Okay, how many electrons?
35.
It will be Sam 35. Okay, how many neutrons?
45.
That is your 80 minus 35, because A minus Z, isn't it? So that's how many? 45, right? So then if I'm just giving you a question like this, for example, you have to tell the symbol of an element which has 18 electrons, 16 protons. So can you tell me the symbol of this?
Sulfur 2 minutes.
What will be the symbol sulfur?
2 minutes.
Exactly, it will be sulfur divalent negative. That means 2 negative. Because sulfur, its atomic number, we know that it is 16 and mass number is 32. So it has 16 protons in it. And when it is now here 18 electrons, so that means it has actually gained 2 electrons. So 16 plus 2, that's 18. So that's why it will be S2 negative, correct? Isn't it? So shall I give more examples or shall we move ahead? Shall I give more examples or shall we move to the next? Next, we have to actually study. Yes.
Next topic, sir.
Okay, so what are isotopes? So isotopes are your atoms of same element having different mass number. Atoms of same element having different mass number, right? Having different mass number. So they have same atomic number. So they are actually the atoms of same element, but they have different mass number. For example, if we are just talking of hydrogen, we are having the 3 isotopes, that's 1H1, similarly 1H2 and 1H3. So they are also having the special names. So this is known as protium. This is known as deuterium. And this is known as tritium. Isn't it? Some may call it as tritium, but better is to pronounce it as tritium. So we are having these 3 isotopes, well-known isotopes of hydrogen. So they are just represented by capital P. This is represented by capital D, and this by capital T. Now, sometimes question is here asked that which isotope among these is radioactive? Can you tell me which is radioactive isotope among these 3? Exactly, it is your tritium, because I have already told you that radioactive elements are those which are having unstable nucleus, and I have told you that why they are having unstable nucleus, because they are actually heavy. Since this tritium, it is having mass number 3, so it is heavy, so that's why it is your radioactive. Got it? Okay, now similarly you can give the another example, that of carbon. So carbon, we are having 612, one of the isotope. Then we are having 613, it's your another isotope, and similarly 614. So they are atoms of the same element but having different mass number. Similarly, you can take the chlorine, atomic number 17, mass 35. Another isotope is 1737, right? So we are having various isotopes. For example, oxygen, we are having 816. Similarly, 8. We are having 870, 880. Am I audible?
Yes, sir.
So have you got it? What are isotopes? So can you tell me, in these isotopes, are they having same number of neutrons or different? Are they having same number of neutrons or different number of neutrons?
Sir, different number of.
Exactly. So you will remember that isotopes have different number of neutrons. So they do not have same number of neutrons, they have different number of neutrons. For example, if you just talk of this protium, so can you tell me how many neutrons are there?
0.
Exactly, it is 0 because 1 minus 1, that is 0. And how many neutrons are there in the deuterium?
1.
It is having 1. Okay, how many neutrons in this tritium? 2, isn't it? So they have different number of neutrons, but can you tell me how many electrons are there? That means, are they having same number of electrons or different number of electrons?
Same.
Isotopes have different number of neutrons, but same number of electrons, right? Same number of electrons. Electrons are here same, neutrons are different. They have same number of electrons. Because here atomic number is 1, so that means it has 1 proton. Similarly, it has also 1 proton. It has also 1 proton. So, but they have same number of electrons and protons. So they have same electrons and protons, but they have different number of neutrons. Got it? This is very important. Now, on the basis of this, can you tell me, are these isotopes having same physical properties, same chemical properties, or different chemical properties? If I'm talking of chemical properties, will isotopes have different chemical properties or same chemical properties? No, isotopes will have same chemical properties because they have actually same number of electrons. Chemical properties, they depend upon the number of electrons. Since they have same number of electrons, so they have similar chemical properties. So I will write it on the next page. Have you written down? Have you noted down this? Have you noted down?
Yes, sir. Sir, but
Okay.
what
Yeah, tell
tritium
me.
is, sir, you know, tritium is radioactive.
I told that tritium is radioactive. Yeah,
And the rest of the other isotopes of hydrogen are not radioactive. So how can all the isotopes have the same chemical properties?
exactly. I will tell you. See, first of all, I will write it here that isotopes have similar chemical properties. So they have same chemical properties because actually chemical properties, they depend upon the number of electrons. Since they have same number of electrons, so that means their chemical properties will be same. Whether it is radioactive or whether it is not radioactive, it doesn't depend on that. For example, okay, I will tell you. For example, it is my protium. When this protium, it reacts with the oxygen, it forms you water. So that's your H2O. But now if you are having this deuterium, when it also reacts with the oxygen, it also forms the water. But that water is known as heavy water, but it forms the water. That means they have same chemical properties. Similarly, if you are just taking the tritium, it will also form the water, but being radioactive, it usually doesn't react. But when if it forms the water, it will be same, that is T2O. So they have all similar chemical properties. Radioactivity, that is different. That is, its nucleus is unstable. It will actually emit various radiations, but chemical property will be same. That means as protium and deuterium, they react with other elements, tritium will also react in the similar way. Got it?
Yes,
Exactly. Okay, so these were our isotopes. So they have similar chemical properties. Now, shall we move to the isobars? For example, another example of isotope, you are having uranium 92 atomic number, 235, it is the mass number, and similarly uranium 92 and 238. So they are also your isotopes, right? Now, what are
Yes, sir.
isobars? What are isobars?
The isobars are atoms with same mass number but different atom.
Yes. So can you define like this, that isobars are atoms of different elements? Can we say they are atoms of different elements?
Yes, sir.
Exactly. Isotopes were the atoms of same element, but here you will write they are atoms of different elements. Atoms of different elements having same mass number, isn't it? Having same mass number. So they are atoms of different elements having same mass number. So they are your isobars. So can you just give the example? For example, if I'm just having here,
Carbon 14.
yeah, argon atomic number 18, mass number is 40. Similarly, if I'm just taking calcium atomic number 20, mass is also 40. So they are your isobars, isn't it? Correct?
Yes.
Okay. Shall I move to the next page?
Yes, sir.
Okay, for example, if I'm just writing here, I'm having carbon 614. This is one of the isotope of carbon. And I'm just writing nitrogen 714. So can you tell me, are the isotopes or isobars?
Isobars.
Exactly, they are also isobars because they have a different atomic number and they have same mass number, isn't it?
Yes, sir.
Yeah, so they are your isobars. Now, can you tell me in these isobars, is the number of neutrons same or different? Can you calculate number of neutrons in these?
So
So it is
neutrons.
14 minus 6, that is 8. And here 14 minus 7, so that is how much? That is 7. So that means they have, isobars have different number of neutrons, right? They have different number of neutrons. So do you remember that isotopes, they were also having different number of neutrons? Isn't it? Isotopes were also having different number of neutrons. Got it? Now, can you tell me, will these isobars have similar chemical properties or different chemical properties?
Sorry, different.
Exactly, they have different chemical properties because they contain different number of electrons, isn't it? So you had to remember that whenever electrons are different, they will definitely have different chemical properties, because here we are having how many electrons are there in this isotope? There are 6. And how many electrons are there? There are 7 in this nitrogen. And similarly, you can also calculate the protons. Protons are here 6, and protons here are also 6. There are 7 protons. So they have different number of electrons, so they have different chemical properties. Clear? Got it? Any doubt here? Then let's see what are your isotones. So isotones are actually those atoms of different elements which have same number of neutrons. So I will write it here that they are your atoms of different elements having same number of neutrons, right? Having same number of neutrons. So we have seen that in case of isotopes, number of neutrons were different. In case of isobars, number of neutrons were also different there. But here in case of isotones, we are having same number of neutrons. Otherwise, they are also atoms of different elements. Clear? For example, if you are just taking C630, so how many neutrons are there? 7. Now, if I'm just taking nitrogen 714, how many neutrons are here? Also 7. So they have same number of neutrons. So that's why they are your isotones. Is it clear? Have you got it? Very easy to understand that in case of isotopes, they were having different number of neutrons. In case of isobars, they were also having different number of neutrons. But in case of isotones, they have same number of neutrons. Otherwise, they are atoms of different elements. Got it?
Yes, sir.
Yeah, for example, I will give another example. We are having oxygen 816, right? If I'm just writing nitrogen 750, so can you tell me, are the isotopes isobars or isotones? So here the number of neutron, it is 8. Here it's also 8. So what are they? They are also your isotones, isn't it? Got it?
Yes, sir.
Have you written down this? Have you noted down? Now, can you tell me these isotones, will they have same number of protons or different number of protons? Can you tell me isotones, will they have same number of protons or different number of protons?
So different.
Exactly. So you will write that isotones have different number of protons. Now, can you tell me, will they have different physical properties or similar chemical properties?
Different.
Different.
Exactly. So they have different number of protons and have different chemical properties. Different chemical properties. Different chemical properties. Then let's see the next one. They are known as isodiaphers. Isodiapher. So can you tell me what are isodiaphers? They are your atoms of different elements. Atoms of different elements having same neutron axis. Having same neutron axis. So how to calculate this neutron axis? That is actually calculated as number of neutrons minus number of protons, n minus p, neutron axis. Got it? N minus p, that's your neutron axis. So you can just write a formula here to note down this, that this neutron axis, it is always equal to n minus p, number of neutrons minus number of protons. Got it? So let's give the example. For example, if we are just having, let's say we are having carbon and we are having this nitrogen. Let's say its atomic number is 6. Here its atomic number is 7. Mass number here is 13. And let's say here it is 50. So can you tell me, are the isotopes isobars or isotones or isodiaphers? You have to just start from the first, that's your isotopes. So can you tell me, are they isotopes? No, because isotopes have same number of same mass number. And they have same atomic number but different mass number. So they are not your isotopes. So can you tell me, are they isobars? They are also not your isobars. because in case of isobars, you are having same mass number. Now, can you tell me, are the isotones? So just calculate the number of neutrons. Here it is 13 minus 6, that's 7. Here it is 15 minus 7, that is 8. So they have different number of neutrons, so they are also not your isotones, correct? Then what they are, so you will just calculate the neutron axis. So how to calculate the neutron axis? It is represented by Ne, so that's your number of neutrons minus number of protons. So that's your 7 minus 6, that's equal to 1. Here it is also neutron axis will be equal to a neutron, that's 8 minus number of proton, that's 7, so that's equal to 1. So when they have same neutron axis, so they are known as isodiaphers. Got it now? Have you got what are isodiaphers? Yeah, simply you will remember that they are atoms of different elements having same neutron axis, and neutron axis is calculated as n minus p. That's number of neutrons minus number of protons. Have you noted down this? Shall we move to the next page?
Yes.
Okay.
Yes, sir.
Okay, so now tell me that if I'm just giving you the example, you have to tell me what are actually those. You take the uranium. Okay, I will write it here. One is your uranium 92 235. Another is your thorium. Thorium is one of the element having atomic number 90 and 234. So can you tell me what are they? Are they isotopes? Are they isobars, isotones, or isodiaphers? So first of all, tell me, are they isotopes? No, because isotopes have different isotopes have different mass number, but they have same atomic number. So since they are not having the same atomic number, so they are not your isotopes. So can you tell me, are they isobars? Are they isobar? Isobars have same mass number, so they are not having same mass number, so they are also not your isobars. So are they isotones? Isotones have same number of neutrons. So can you calculate the neutron? It is 235 minus 92. So how much it will come out?
143.
143, right? Okay, how many neutrons are here in this theorem? That is 234 minus 90.
144.
1.
42.
144, right? So can you tell me, are they having same number of neutrons? Are they isotones? Are they isotones? No, they are not your isotones, because isotones have same number of neutrons, but they are having different. Now, can you tell me, are they isodiaphers?
Yes, sir.
Are they isodiaphers? Have you calculated? So how many protons are here? Protons are 92, and here the protons are 90. So when you just calculate the neutron axis is n minus p, so that is 143 minus 92. So how much it will come out? How much it will come? Yes,
51.
51. Okay, now can you calculate here the neutron axis? That is 144 minus 90. That is 50.
Four.
So are they having same neutron axis? They are having different neutron axis. So that means they are also not your isodiaphers. Got it? This is very important that you should be able to calculate to tell that whether they are isotopes, whether they are isobars, whether they are isotones, or whether they are your isodiaphers. Okay, I will just give you one more example. Now, if it was just like this, if it was your uranium 92, 238, and if it was your thorium 90 and 234. Now, can you tell me what are these? So first, just start from the isotopes. You have to just start from the isotopes. So tell me, are they isotopes?
No, sir.
No, they are not at all. Okay. Are they isobars? No, they are not your isobars. Because isobars, they should have same mass number, but they are having different. So can you tell me, are they isotones?
Sir, is that 235 or 238?
It is your 238 and here it is 235, 234. Now tell me, are they isotones? Can you calculate the number of neutrons in these?
Sir, they're not.
So how many neutrons are there?
146.
Exactly. Okay. How many neutrons here? 144.
144.
Okay. So they are not your isotones. So now can you tell me, are they isodiaphers?
Yes, sir.
Yes, sir, they are.
Exactly. They are your isodiaphers because what is here? The neutron axis. Can you calculate neutron axis? Neutron axis is 146 minus 92.
54.
That is
54.
54. Okay. How many? What is the neutron axis in the next one? That is the thorium 144 minus 90.
52.
That is also 54. So that is why they are your isodiaphers. Have you got it now?
Yes, sir.
Okay. Shall we move to the next page? Have you noted down this?
Yes, sir. we can continue.
Okay. So let's see now what are isoelectronic species. Isoelectronic species. So can you tell me what are isoelectronic species? They are just your species which have same number of electrons, right? Species which have same number of electrons. So they are known as isoelectronic species. So that means why we are just calling them as species, because it can be an atom, it can be a molecule, it can be a neutral atom, neutral molecule, it can be cation, it can be anion. So that's why we are using here the term species. Species. Okay, now tell me, for example, I will just give example. If I'm just writing N3 negative, similarly O2 negative, similarly F negative, fluoride ion, similarly neon Ne, and then Ne positive, and then Mg2 positive, and then Al3 positive. So can you tell me, are they isoelectronic or not? Exactly, all have 10 electrons. So that means they are your isoelectronic species, right? All have 10 electrons. So when all have same number of electrons, so they are your isoelectronic species, right? All have 10 electrons, hence they are isoelectronic, correct? Have you got it now? It's very easy to remember that they should have same number of electrons. Now, can you tell me, are these two isoelectronic, first and the second one? Carbon monoxide, it's your CO, carbon monoxide, and this is your N2 molecule. So are they isoelectronic or not? See, carbon, it has 6 electrons. Oxygen has 8 electrons, so that is total 14. Nitrogen, it has 7 electrons, and here it's also 7. There are 2 nitrogen atoms, so that's also 14. So they are also your isoelectronic, right? Isoelectronic. Got it?
Yes, sir.
Exactly. So I hope that you can now differentiate whether they are isoelectronic, whether they are isotopes, isobars, isotones, or isodiaphers. Let me give one more example. If I'm just writing sulfur 2 negative and it is my Cl negative, so are they isoelectronic? Yes, can you tell me?
Nothing, sir.
They are your also isoelectronic, right?
Yes, sir.
Because they have how many electrons? Because they both have 18 electrons, right? Both have 18 electrons. Sulfur, its atomic number is 16, so it has gained 2 electrons, that's 18, and 17 chlorine and 118. So both have 18 electrons. So they are your isoelectronic, right?
Yes, sir.
Okay. So let me now tell you very important point here. That is actually the order of size. So which will have bigger size and which will have smaller size among these isoelectronic species? That's very important. For example, if I'm just writing here, I was having N3 negative, and then it was your O2 negative, then it was your F negative, then it was your neon, then it was your Na positive, Mg2 positive, and Al3 positive. So can you tell me which will have smaller size and which will have bigger size? You will remember that whenever you have anion, its size is greater than the neutral atom, and its size is greater than the cation. Got it?
Yes,
For
sir.
example, F negative, its size will be greater than neon, and its size will be greater than Na positive. But can you tell me what will be the order for all these? Now you are here having 3 different types of anions. We are having N3 negative, O2 negative, F negative, but all have actually 10 electrons, right? All have 10 electrons. So can you tell me the order of size in all these molecules, in all these species? Which will have a very big size among these? It will be your N3 negative. More the negative charge on the anion, bigger will be the size. So you will remember like this.
Sir, why is that?
Okay, I will tell you the reason. See, actually, all they have 10 electrons. So they have same number of electrons. But can you tell me the number of protons? Here we are having only 7 protons in case of nitrogen. In case of oxygen, we are having 8 protons. In case of nitrogen, we are having 9 protons. So number of protons increase, but the number of neutrons, they remain same. So that is why what will actually happen here, I will write first of all 12 protons, and here it is the 13 protons. Now tell me, in case of N3 negative, we are having only 7 protons and electrons are 10. And here in case of aluminum, Al3 positive, we are having 10 electrons, and here protons are 13. So where will be the more force of attraction? Can you tell me where will be the more force of attraction? Are you getting this? See, in case of aluminum, you are having 13 protons. So that means 13 positive charges there in the nucleus. And now you are having how many electrons? You are having 10 electrons. So just like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But in case of nitrogen, you are having only 7 protons in the nucleus, that is plus 7 charge, and electrons are also 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, where will be the more force of attraction between the protons and the neutrons? Can you tell me? Where will be the more force of attraction? It will be here where we are having 13 protons. See, 13 protons, they are just attracting only 10 electrons, isn't it? So there will be more force of attraction, isn't it?
Yes, the force of attraction is more, the size will be small.
Exactly. When force of attraction is more, the size will decrease. It will just contract. So that's why it will have smaller size. And here we are having only 7 protons. So the force of attraction will be less. So you will note down this, that here force of attraction is less. So that is why size will be bigger. And here the force of attraction is high. Force of attraction is high. So that is why its size will decrease. It will just contract. So that is why this is the order. I hope you will remember this order of size. So N3 negative, it will have very bigger size as compared to O2 negative, and then F negative, and then it will be the neon, and then Ne positive, then Mg2 positive, and then El3 positive. So have you got it?
Yes, sir.
Shall I move to the next page?
Yes, sir.
Now tell me if I will just write, I'm just having here S2 negative, Cl negative, and let's say I'm having argon. Let's say I'm having K positive potassium. I'm having here the calcium. I'm having here the okay, let's see, we're having phosphorus here, phosphorus 3 negative. So can you tell me the order of size among these?
Sir, P3 minus S2 minus Cl minus Ar, A plus and Ca plus.
Yeah, P3 minus, then which will be the next?
Sulfur 2 minus.
Exactly, then it will be your Cl minus, then
Argon.
argon, then it will be K positive potassium, and then it will be calcium. Got it? Yeah, so this is the order of size. I hope you have understood this. So any doubt, any question here? Is it clear?
Yes, sir.
Okay. Now, can you tell me then, these are your isoelectronic species. Okay, can you tell me, are these isoelectronic if I will just write NO and O2? Are they isoelectronic, these two? Are they isoelectronic? It's your nitrogen monoxide and it's your O2 molecule, oxygen. Are they isoelectronic? Yes, can you tell me? Ratika, can you tell me, are they isoelectronic?
Yes, sir.
No, they are not isoelectronic. See, nitrogen, it is having 7 atomic numbers. So there are 7 electrons. Oxygen is having 8 electrons. So that means total we are having 15 electrons. But here oxygen, it is 8 and 8. That is your 16. So how they can be isoelectronic? They have different number of electrons. So that means they are not isoelectronic. Got it?
Yes, sir.
But if I will just write like this, for example, if I will just write NO and O2 positive. So can you tell me now, are they isoelectronic?
Yes, sir.
Yes, they are isoelectronic, right? Can you tell me why they are isoelectronic? Because NO, it has 15 electrons and it is also having 15 electrons. That is 16 minus 1 because it has now one positive charge, isn't it? Got it?
Yes, sir.
Okay. So let's revise what we have studied today. So we just started with the discovery of neutron. I told that neutron, it was discovered by Chadwick in 1932. And how neutron actually got discovered, I told that it was just the bombardment of alpha particle with the beryllium nucleus, right? Simply when an alpha particle, it is just thrown, it is just bombarded on the beryllium nucleus, then there was discovery of a neutral particle which was just observed having a mass of 1.675 into 10 to the power minus 28 kg. So that is actually your minus 27 kg. That's your neutron. It is neutral, it is having mass same as that of proton, but its mass is slightly greater than that of proton. Is it right? Yes. So then I told that we can also discover this neutron just by bombarding alpha particle with the boron nucleus. So these are your nuclear reactions. So with the help of nuclear reaction, you can convert one atom into another. This is very interesting. For example, if you have to just convert copper into gold, you can do this. This is known as nuclear transmutation. This nowadays very important technique. If you just want to convert one nucleus into another nucleus, you can do it by nuclear transmutation. So then with the help of discovery of neutron, then we just studied what is atomic number. So I told it is represented by Z. It is the number of protons. You can also say it is the number of electrons, but it should be your neutral atom, because if we are having a charged atom, then the number of protons, it will not be equal to the number of neutrons. It will be only equal if we are having a neutral atom. And then I told that this mass number, that is the sum of number of neutrons and number of protons. So that means mass number that is represented by A, it is always equal to N plus P, that is the number of neutrons plus number of protons. And how to calculate then the number of neutrons? I told that number of neutrons, that is calculated by A minus Z, that is atomic mass number minus atomic number, A minus Z. So that is the number of neutrons. And then I told regarding what are isotopes. They are just your atoms of same element having different number of neutrons, isn't it? Isotopes have different number of neutrons, and isotopes have different mass number. They have same atomic number, so they have similar chemical properties. This is very important to be noted down, that isotopes have similar chemical properties. Then isobars, I told that isobars are atoms of different elements having same mass number, isn't it? Just we're having calcium, mass number is 40, and just we're having argon, atomic number 18, mass number is 40. So they are your isobars. And then I told what are isotones. Isotones have same number of neutrons. This is very important to be noted down, that isotopes have different number of neutrons, isobars have different number of neutrons, but isotones have same number of neutrons. And then I told isodiaphers. Isodiaphers are the atoms of different elements having same neutron axis. And I hope that you have remembered what is neutron axis. It is N minus P, number of neutrons minus number of protons. So I just give you the example of uranium and thorium, similarly carbon and nitrogen. And then isoelectronic species, I told that they are those species which are having same number of electrons. So just I give the examples, and I also told how to calculate the size of these isoelectronic species. So anion is having always bigger size than the neutral atom, and then the cation. Cation will be always having smaller size. So any question, any doubt in today's session? Any question from anybody?
No, sir.
So have you revised the previous 2 classes which we have taken?
Yes, sir.
Okay, if I will just ask you that, how much was the voltage of HT battery which was taken during the discovery of proton
10,000.
and
10,000 volts.
yeah, it was 10,000. Okay. Now, okay, so this was the discovery of proton and electron. So can you tell me who actually coined the term electron? Amrisha, can you tell me who coined the term? Which? G.J. Stoney it was. Who coined the term electron? It was G.J. Stoney. Isn't it? Have you noted down this? Electron was discovered by J.J. Thomson, but the coin was given by G.J. Stoney. Electron term was coined by G.J. Stoney. Have you got it? Who told that this electricity is made up of atoms of electricity? Atoms.
Sir, can you repeat?
Yes. Okay, Stesh, can you tell me that what is fogging? Stesh, you have to tell me what is fogging.
What is
Fogging, F-O-G-G-I-N-G, fogging. That means you are not revising at your home. I have just told this fogging in the properties of cathode rays. You just
Sir,
check it out.
they
Properties
affect
of,
the photographic film, that thing.
exactly. When cathode rays, they just fall on the photographic film. It affects the photographic film. This phenomena is known as fogging, right?
yes, sir.
Yes. Okay, so can you tell me what is phosphorescence? Yes, phosphorescence. Meghna, can you tell me what is phosphorescence? Yes, phosphorescence.
Sir, glowing of zinc, sir.
Yeah, actually, whenever we are having this zinc sulfide screen, it is your phosphorescent material. When any particle strikes this zinc sulfide screen, it starts glowing, and this phenomena is known as phosphorescence, right?
Yes, sir.
Okay, I hope that you will keep revising, you will study at your home. Whenever you have any doubt, any question, you can just let me know. Thank you. Have a nice day ahead. Wish you all the way best.
Thank you, sir.